Hey, hello, welcome back. In this part, we are going to take a look at non-standard stack frames. Okay, so frequently reversers will come across a subroutine that does not set up a standard stack frame, and here are some things to consider when looking at a subroutine that doesn't start with a standard sequence. Okay, so let us take a look at using uninitialized registers. Okay, so when a subroutine starts using data in an uninitialized register, that means that the subroutine expects external functions to put data into that register before it gets called. Okay, and some calling conventions pass arguments in registers, but sometimes a compiler will not use a standard calling convention. Okay, so let us take a look at the static functions. Okay, so in C functions may optionally be declared with the static keyword. Okay, such as, for example, such as you can have static. Okay, static, then it's a void function. Okay, and then you can have my function like that, my function for like that. Okay, like that. Okay, and the static keyword causes a function to have only local scope. Okay, and meaning it may not be accessed by any external functions. Okay, and it is strictly internal to the given code file. Okay, and when an optimizing compiler sees a static function that is only referenced by calls, which means no referenced through function pointers, it knows that external functions cannot possibly interface with the static function. Okay, and the compiler controls all access to the function. Okay, so the compiler does not bother making it standard. Okay, so let us take a look at the local static variables. Okay, so local static variables cannot be created on the stack since the value of the variable is preserved across function calls. Okay, so we shall discuss local static variables in other and other types of variables in later parts. Okay, but not in this part. Okay, so in the next part we shall take a look at functions and stack frame examples. Okay, so thank you. If you have liked the video, thank you.